Okay, this lesson is on graphing quadratic functions. A quadratic function, at least in standard form, is f of x equals ax squared plus bx plus c. And when we graph a quadratic function, we get a parabola. The simplest possible quadratic function that you could have is y equals, or f of x equals, x squared. And so we're going to graph that, and we'll just plot some points here. If I plug these values in for x, let's see what we get for y. If x is negative 2 and I square it, I will get 4. If x is negative 1, I square that, I get 1. X equals 0 gives me y equals 0. This will be a 1, and this will be a 4. If I plot those points, I get negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So the points, connect the dots, and we get our parabola. This is y equals x squared. Let's fix that. There we go, a little bit better. The important features of a parabola: the lowest point here, or if the parabola opened upside down, it would be the highest point. That is called the vertex. A parabola is symmetric. One side is supposed to be just like the other side. And so the parabola has what's called an axis of symmetry, right down the middle, axis of symmetry. Now let's compare this to if we graph y equals x squared plus 2. Now if I plot some points for y equals x squared plus 2, if I start with negative 2 and I plug that in, I actually get a 6. If I plug in negative 1, I'm going to get a 3. If I plug in 0 for x in here, I'm going to get 2. And then a 1 will give me 3, and a 2 will give me 6 again. Now let me plot those points, and I'll use green here. Negative 2, 6 is here. Negative 1, 3 is here. 0, 2 is here. And here are the other points. Connect the dots. And this is the graph of y equals x squared plus 2. Now notice what happened when I added 2 on the end of x squared. The only thing that happened is the parabola just moved up 2 places. And so its vertex now is located at 0, 2. This one's vertex is at 0, 0. Okay, so we know how to move a parabola up and down now. You just add a number on the end. For example, y equals x squared plus 3. The vertex would be at 0, 3. If I subtract a number on the end, for instance x squared minus 1, that would move the parabola down. Its vertex would be at 0, negative 1. So we know how to move a parabola up and down. Now, if I graph y equals x minus 2 squared, let's see what happens here. I'm going to plot points again. Table of points. If I plug in 0, I get 4. Right there. If I plug in 1, net 1 minus, let's see. If I plug in 1, that's going to be 1 minus 2 squared. That's actually going to be a positive 1. If I plug in 2, I get 0. If I plug in 3, I get 1. And if I plug in 4, I get 4. And so notice what happened when I put a minus 2 inside the squared term with the x. The parabola moved 2 to the right. And so the vertex here is now at 2, 0. So if I put an x minus 2 inside with x, minus 2 in there with x, that moves the parabola 2 to the right. Let's try y equals x plus 3 quantity squared and see what that does. If I plug in 0 here, I get 9. Can't really fit that on our graph. If I plug in, let's see, negative 1, I get 4. I can fit that on. Use green here. If I plug in negative 2, I get 1. If I plug in negative 3, I get 0. If I plug in negative 4, I get 1. And if I plug in negative 5, I get 4. Connect the dots, and here's our parabola. This one is y equals x plus 3 squared. This one over here was y equals x minus 2 squared. So notice what happened when I graphed this. The parabola has been moved 3 to the left. Our vertex here is at negative 3, 0. And so we now know how to move a parabola left and right. Notice that in all the examples I've done so far, the shape of the parabola has not changed, only the location of the vertex. Now let's graph y equals 2x squared. Let's see what happens if we multiply x squared by 2. I'm going to plot points again, make a table of points. If x is 0, y will be 0. If I plug in 1 for x, I get y will equal 2. If I plug in negative 1 for x, I'll also get 2. If I plug in 2, 2 squared is 4 times 2 is 8. So it's way up there, I can't even fit it on there. And also negative 2 will give me 8. And so this parabola goes up very fast, and it is skinnier than y equals x squared, narrower than y equals x squared. So multiplying the x squared by a number larger than 1 actually makes our parabola skinny. If I multiply it by a fraction, some number between 0 and 1, this will make the parabola wider. For example, y equals 1/2 x squared. We'll go through the ordered pair 0, 0. If I plug in 1, I get 1/2. If I plug in 2, I will get 2. Let's try some negative numbers. If I plug in negative 1 for x, that'll give me positive 1/2 for y. And negative 2 will give me positive 2. And so plotting these points, you're going to notice that the parabola is wider. So what we're learning here is that this number in front of x squared, which is what's going to be the a in a minute, the a term or coefficient, determines the shape of the parabola, determines how wide or narrow the parabola is. It also determines which way the parabola opens, whether it will open up or down. For example, if I graph y equals negative 2x squared, a few points that this will go through will be 0, 0, let's use green here. 0, 0. It will also go through -1, comma, -2, and +1, comma, -2. And so notice what happened when a, or the number in front of the x squared term, the a here, is negative, then the parabola opens downward instead of upward. So a not only determines the shape of the parabola, but it determines which way the parabola opens. Okay, to summarize what we have so far now, if we have a quadratic function in this form, this is called the completed square form, I can tell just by looking at it where the vertex is located. The vertex is located at hk. There's the h and there's the k right there. Here are some examples. Find the vertex. Y equals x minus 3 squared plus 1. Following this here, the h is 3 and the k is 1. Notice that in here you see a minus sign. I don't write -3 for the vertex, it's just the 3. It's sort of the opposite of what's inside the parentheses. And so this has a vertex at, the vertex of this parabola is at 3, 1. One half times x plus 2 squared plus 3. And the vertex is right here. It's sort of the opposite of what we have in there. Remember that x plus 2 moves our parabola to the left 2, and so the vertex will be located at -2, comma, +3. Here's another one. -3 times x plus 1 squared minus 4. This parabola has been moved 1 to the left, so that'll be a -1 from right here. And it has been moved down 4, and so our vertex is at -1, -4. A couple more. 5 times x minus 1 quantity squared. Okay, this parabola has been moved 1 to the right, and so its vertex will be at 1, 0. There's no k on the end there, it's 0 there. And one more. Y equals -1/3 x squared minus 2. It has been moved down 2, but it hasn't been moved left to right, and so the vertex is located here at 0, -2. Okay, so when our quadratic function is in this completed square form, we should be able to look right at the equation or the function and see where the vertex is located. Also notice in these problems the a value. And the first one here, a equals 1, and so that tells me, because a is positive, this parabola opens upward, like that. This a value is positive, and so this parabola also opens upward. But because that's a fraction between 0 and 1, the a is a 1/2, I know that this parabola is going to be a bit on the wide side. This a value is -3. Since this a value is less than 0, I know that this parabola will open downward. Opens down. And because it's a 3, that's going to be a rather narrow parabola. And then similarly here, 5 tells me that because it's positive, it's going to open up. And because it's a large number, it's going to be a narrow parabola. And then finally, -1/3 here. It's negative, so it opens downward. and because it's a 1/3, I know it's going to be a wide parabola. Okay. So what do we do if we want to find the vertex of something like this? What if our equation is not in that completed square form? What if it's something like x squared minus 4x plus 5? And I want the vertex of the parabola. There's a couple ways to get it. The method I'm going to show you right now is the completing the square method. I'm going to write that in the completed function in the completed square form. And the way I do that is I move the 5 out of the way like that, and then I complete the square. And we have discussed this in a previous section. The number that I need to add in here to complete the square, if you recall, I take half of this, which is 2, and then we square it, and that gives us 4, and that's the number we have to add right in there. Now, to balance this out, I don't want to write anything else over on the left side with y. I want to keep everything on the right side. So to balance out adding 4 to this side, I will subtract 4 from the same side. So I've really added 0, and I haven't changed the value of anything. So plus 4 and minus 4. Now, this in the parentheses factors to a perfect square. It is x minus 2 quantity squared. And then on the end I have plus 1. Okay, and I've written it in this completed square form. And so I can see now that the vertex is going to be located at 2, comma, 1. The vertex of our parabola is 2, 1. Here's another example of that. Y equals x squared minus 6x plus 7. Okay, we're going to find the vertex by completing the square. I move the 7 out of the way. The number that I need to complete the square here, I take half of this 6, which is 3. I square it, which is 9. So I have to add 9 to this side, and on the same side to balance it out, I'm going to subtract 9. Now, what we have in the parentheses there will factor to a perfect square. It's x minus 3 quantity squared. And then on the end we have minus 2. I have it in the completed square form, and so I know that this vertex is going to be located at 3, comma, negative 2. Okay, let's try a couple more of these. So these two are going to be a little bit more difficult than those. Once again, find the vertex. Y equals 2x squared plus 4x minus 1. Okay, to complete the square here, just like before, I'm going to move the negative 1 out of the way, like that. Now, before I can actually add a number in, I have to get rid of this 2 here. To complete the square, it has to be a 1x squared. So I'm going to have to factor 2 out. 2 times x squared plus 2x minus 1. I factored a 2 out of the parentheses. Now, I can add a number in to complete the square. I take half of this, which is 1, and then I square it, and that's a positive 1. So I've got to add 1 to this side. Now, a lot of students will make the mistake of going plus 1 and then minus 1 here, but that would be wrong because I really didn't add plus 1. What I really added here is 2 times that 1. 2 times that 1 is a 2. And so to balance it out properly, a positive 2, I have to go minus 2. Okay, and that comes from there. Now, what we have in the parentheses, factors to a perfect square, it's x plus 1 quantity squared, and on the end I have minus 3. And we have it written now in this completed square form again. Okay, by looking at this, I can see that the a value is 2 here, but that doesn't do anything with the vertex. Our vertex is located at negative 1. Remember, it's the opposite of what's inside there. Negative 1, comma, negative 3. That's the vertex of the parabola. Let's try one more. Find the vertex. Y equals negative 1/2 x squared plus 2x minus 3. Okay, so once again, the first thing I do is move the number on the end out of the way, so that minus 3 goes out there. I need a 1 here, so I'm going to have to factor out a negative 1/2. I don't have a choice. Factor out negative 1/2. So that'll be x squared here. Now here, if I factor negative 1/2 out of there, that means I'm taking, I'll write the work up here, I'm taking 2 divided by negative 1/2. And that is the same as 2 times negative 2 over 1, and that's a negative 4. So I actually have a minus 4x in there. And you can verify that this is correct. If you were to multiply that times that, you would get a positive 2x. Okay, so I have the negative 1/2 factored out correctly. Now the number that I need to complete the square, half of that is 2 squared is 4. I have to add a 4 in there. But it's really not a 4. It's actually negative 1/2 times 4, which is a negative 2. It's actually a minus 2 that I've added in there. And so to balance out a negative 2, I have to go plus 2 on the end. Plus 2. What we have in the parentheses, factors to a perfect square. It's x minus 2 quantity squared. On the end I have minus 1. And so now I have the vertex of this parabola, which by the way opens downward from that. The vertex of the parabola is at 2. Remember, it's the opposite of what that number is, 2. And then here is negative 1. Our vertex is at 2, negative 1 for this parabola. Okay, let's do 1 or 2 examples now of graphing a parabola. Let's graph f of x equals x plus 2 quantity squared minus 1. Now our quadratic function is in this completed square form, and so we should be able to look right at it and identify the vertex. The vertex here is located at the opposite of what's in there, negative 2, and then that number, negative 1. Our vertex is at negative 2, negative 1, so we'll plot that point first. Okay, negative 2, negative 1 is right here. And our a value is right there. A equals 1, and so since a is positive, I know that my parabola is going to open upward. Opens up, like that. Now I'm also going to draw in our axis of symmetry that we mentioned earlier. The axis of symmetry is just a vertical line that goes right through the vertex. Like that. If you want the equation, it's just x equals this value right here, x equals negative 2. That's the axis or the line of symmetry. We talk about that in more detail in the next lesson. Okay, now I'm just going to plot some points. I'm going to pick a value for x, such as 0, and plug it into my function and figure out what the y value is. So I'll do some of the scratch work up here. If I plug 0 into my function here, let me rewrite that function up here. So So y equals x plus 2 squared minus 1. If I plug 0 in there for x, 0 plus 2 squared is 4, minus 1 is 3. So our parabola goes through the ordered pair 0, 3. Right there. Now, I can use the axis of symmetry to get another point. One side of a parabola is supposed to look like the other side, and so if there's a point here, then there must be another point the same distance away over there. Let's try now negative 1 for x. If I plug a negative 1 in, I get 1 squared minus 1, which is 0. And so when x is negative 1, y is 0. That point is right there. But because of symmetry, there would be another point on the other side right there. We have enough points to see our parabola. We can connect the dots. And we have our parabola sketched. Let's try another one now. One more. Let's graph f of x equals 1/2 x minus 2 quantity squared plus 1. Okay, because a is positive, I know that my parabola, this one will open upward. Just like the other one. The vertex is at 2, 1. 2, 1. All right, so let's plot that. Two, 1 is right here. And I'm going to draw in my axis of symmetry. There we go. And this parabola opens upward, so I'm going to make a table of points now. If x is 0, I get 1/2 times 0 minus 2 squared plus 1. If I work that out, that's going to be 4 times 1/2 is 2 plus 1 is 3. So our parabola goes through 0, 3. Because of symmetry, there would be another point the same distance away on the other side of the axis of symmetry right there. Let's try 1. If I plug in 1, I get negative 1 squared is 1 times 1/2 plus 1, 1/2, or I'll write it 1/2. 1, 1/2 is right there. And because of symmetry, we'd have another point the same distance away right there. And that's enough points to see our parabola. Let's connect the dots. And there is our parabola. Let's fix that up. There we go. Okay. Actually, let's do just one more here. We should do graph one that opens downward. Last one. Let's graph y equals negative 2 x plus 1 squared. Okay. Because our a here is negative, less than 0, this parabola will open downward. Open downward. And I know it's going to be a little on the skinny side because it's a 2. It's larger than 1. Or the absolute value of negative 2 is larger than 1. The vertex is at the opposite of that number, which is negative 1, comma, nothing on the end, so it's 0. Vertex is at negative 1, comma, 0. So let's start graphing. Negative 1, 0 is right here. And now let's make a table of points and plot a few points. Let's see. Y equals negative 2, x plus 1 squared. If I plug in 0 for x, I end up with -2. 0, -2 is right here. If I plug in 1, oh wait a second, I forgot, this was my vertex, so my axis of symmetry is right here at x equals -1. So if I have this point 0, -2, then there's another point on the other side right there. Okay, now when x is 1, if I plug in 1, I get 1 plus 1 squared is 4 times the -2 is -8. 1 -8. And I can't even fit that on. It's too low. 1, 2, 3, 4, 5, 6, 7, 8. It's way down here. And so I'm going to sketch my parabola now. It's very skinny, rather skinny parabola, which looks somewhat like that. Okay. And that is how we graph parabolas. Part 2 of our lesson is coming up.